All right, in this video, we're going to talk about some ideas from 7-10, both of those days, and putting it together with 7-11, where we're going to just put together the different transformations for sine and cosine graphs, such as amplitude, vertical shifts, phase shifts, and period changes, and how we deal with graphing when there's many of these put together instead of just one transformation. So there is a certain order that we kind of need to deal with these things. We're going to do the phase shift and the period kind of can go together. Those are both horizontal things. And we're going to deal with that first, which kind of has to do with our labeling of the axes. And then we need to deal with amplitude, which kind of stretches things taller or reflects it. And then always the very last step is the vertical shift if there's something added or subtracted on the end, which will just move the whole graph up or the whole graph down. Okay, so let's look at a couple, just starting out with only a couple of the transformations, and then we'll add into where there's all of them being changed. So this is all in degrees as well. So first one we have here is going to be y equals 2 times cosine of x minus 1. There's going to be an amplitude of 2. And there's a vertical shift of either down 1 or you could say minus 1, something like that, right? So I'm going to draw the regular intervals here. It's really important that we label everything because as we've seen before, these can change, right? I like to draw the regular graph and kind of change things one layer at a time. So we're doing cosine. So that's going to start up at 1, 0, negative 1, 0, positive 1, and I just like to draw a dashed line. Just that's my basic graph. All right, that's our parent function for the cosine graph. So then what we're going to do in our order of things, we only have the amplitude and a vertical shift. So we need to deal with this amplitude first. So as we said before, we're going to multiply the cosine values by 2. And if you think of the order of operations, you would be doing this multiplying by 2 before you subtract 1. So that's why we would need to do the amplitude first, and then we'll do this at the very last step. So all of these y values of really 1, 0, and negative 1 are going to all be multiplied by 2, right? So I'm going to change my axis a little bit here because I know I'm going to need a little bit more. So this times 2 brings it up to positive 2. This one times 2 is going to stay the same. This times 2 is now at negative 2. This one stays the same. And this one's at positive 2. And I'm going to draw a dashed line through these points. Hopefully you can see this is green. So that's not my final answer either. That's just 2 times cosine of x. But I have one last part, which is that vertical shift down. And I think I'll just use this pink pen here. So I'm just going to take all of these values and move them down one spot. Right? So all these green ones are going to move down. So this one actually goes back to where it started. This one's going to move down 1 to be at negative 1. This one's going to move down 1 to be at negative 3. So I need to extend that down a little bit more. Down 1 at negative 1. Down 1 to be back at 1. Right? So our pink here happens to be the final version of this entire equation. Right? We did the amplitude first. Then we moved everything down 1 unit. Okay. Let's take a look at another one where we just have the amplitude and the vertical shift happening. So this one says y equals negative 3 times sine of x plus 2. So first of all, it's good to identify maybe our amplitude and our vertical shift. Now our amplitude is always positive. It's always representing a distance. So even though there's this negative 3 here, our amplitude is technically just 3. I'm going to put a little star or something to know that I need to be flipping the regular sine curve. It should be reflected, right? And we're still going to multiply by negative 3, but when it's asking for the amplitude, that's the distance between the top and the middle. Like for here, for this pink one, that was our final answer. Here's the middle, and that was called the midline, if we go cut through where the middle is. Between the top and the middle, this one happens to be a unit, 2 different units, right, separating it. Between the bottom and the middle, that's also 2 units, and that's why our amplitude is 2. So in this next one, there should be a distance of 3 units between the top and the bottom. And the 3 is just representing that. So the negative part is not really explaining the distance and that's what the amplitude does. Vertical shift is it moves up 2, or you could write plus 2, whichever way makes more sense to you. Okay. We have our same intervals here. All right, so here's 1, here's -1. And I'm going to just draw my regular sine graph this time. So sine starts at 0, then goes to 1, 0, -1, 0. So I'm just going to connect those with the dashed line. That's my basic parent function. Right? So according to our kind of steps or order of operations, we're going to multiply all of our y coordinates by -3 first to stretch it and to reflect it. So if I do that, I'm going to have to change quite a few of these numbers. Let's do that. Here's going to be -2, there's -3. Right? So starting from 0, if I multiply that by -3, that's going to still be there. 1 times -3 flips it down to -3, right? We're still multiplying by -3, even though the amplitude is technically only +3. This times -3 is still the same. -1 times -3 moves up to +3, and then this one stays the same. So my green shows the amplitude in this multiplying by -3 part. It's stretched taller and it's flipped over. It's reflected. Okay? Our final piece is dealing with the +2. So we're going to move all of our points up 2 units directly above from where they were. So this one up 2 is now at 2. This one was at -3, moving it up 2 is at -1 now. Up 2 from here is at 2. Up 2 from 3 would be 5. I'm going to attempt to show that on here. And it's really important that you label this y-axis as well as the x-axis. And this up 2 should be at 2 again. Okay? So hopefully you can tell these different colors here. So my pink one is the final version of this entire equation right here. All right? So that's when we have amplitude and a vertical shift kind of dealing with those 2 orders. Now when we add in a horizontal change of some sort, we'll look at some of those. Okay. So I actually have a couple of the homework questions as examples here. So this first question, y equals cosine of 3x plus 2, is from a 7-10 day 2 homework, and it's number 12. So if you happen to look through that, that's where this one's coming from. Okay. So it's a good thing to just kind of identify what is actually changed, what is transformed from the regular cosine graph before we get started. So this +2 on the end is that vertical shift again. So you can either say up 2, +2, whatever. And the number inside being multiplied, it tells us that there's a period change.